In this video, we're going to take word problems and turn them into table of values and then into linear equations. So in this question, Aubrey bought a tomato plant, put it in a pot, and put it on his back deck. When he purchased it, it was 10 inches tall. From that point, the tomato plant grew at a rate of 2 inches per month. Use H to represent the plant's height and M to represent the number of months that have passed since the plant's purchase to make a table of values. Then, write an equation for H in terms of M. Okay, so what's happening here is we have a linear situation and they want us to write it as a linear equation. They also want us to make a table of values. So when you're determining your table of values, usually you're going to use X and Y. In your table of values, the X coordinates, the X values, are usually your independent variable. That's usually the information that you have control over, right? And the Y is usually something that is dependent on the X. So in this case, the height of the plant is the dependent variable. The height of the plant is completely reliant on the number of months that have passed, right? So now we don't have control over the number of months. We don't have control over time, right? But that's the thing that's going to change, and the plant is going to respond to that based on how much time has passed, right? So normally equations use X and Y. In this case, the equation is actually going to use T, or actually they use M, so M and H. So this table is an MH table, and usually we use an XY table. It's the same information. So let's just pretend that we start at 0 months, and then we just keep adding months to this information. So at 0 months, whenever you use 0 as the independent variable, whenever you use 0 for X, what that means is that nothing has happened yet, right? In this word problem, nothing has happened yet. No time has passed. And by the way, I want to point out, I forgot to mention this. Usually, I would say most of the time, the X coordinate is time, because time is usually what everything else is based on. All right, so in this case, if no time has passed, how tall in inches is this plant? And they told us that it's 10 inches tall. Now, if we change M to 1, if suddenly a month later, how many inches tall is this plant? And it's going to be 12 inches tall because they told us it's going to change 2 inches per month. It's growing at a rate of 2 inches per month. So to get the H column, all I would have to do is keep adding 2. So that table of values represents this situation. As we increase the months, it looks like our height, it goes up by 2. If we were to calculate the slope of this table, the rate of change of this table, it would be 2 inches per month. We should have known that this was the rate of change because it says rate right here, and because it used the word per. And the word per usually is an indication that that's your rate of change. So now they want us to write this as an equation. But before I do that, I'd like to plot these as points in a table here. So let's make a table here. Table. So let's do 0, 10, and 1, 12, and 2, 14, and 3, 16, and 4, 18. So yeah, as you can see, as expected, we have a linear relationship here. The dots are increasing at a constant rate. And now they want us to write this as an equation. So remember, to write an equation, we need to find two things for a linear equation, that is. We need to find the rate of change, and we need to find the y-intercept. So the y-intercept is where everything started. The y-intercept is where no time has passed, right? So the y-intercept here is 10. And the rate of change is how much it's changing per month or per day or per whatever the time measurement is. Now, in this case, it was month, and they already told us the rate of change is 2. And it's 2 inches per month. And the y-intercept is 10 inches, right? So normally, a linear equation looks like this. Y equals mx plus b. But because this problem is using h's and m's, we're going to change the y to be h. And we're going to change the x to be m. Now, unfortunately, m represents the number of months, and m is usually the slope, right? So I'm going to say, just underneath here, I'm going to say this is slope and this is months, just because I don't want to get them mixed up. And b is still going to say b, right? So to represent this as an equation, the variables we use in the problem are going to stay as m and h. And we know that because up here it says, then write an equation for h in terms of m. For h means that they want the h to be alone. In terms of m means that all the m's should be on the other side. All right, what that means is when we're done, our variables h and m should stay as variables, right? So instead of changing those h and the m to numbers, we're going to leave them in the equation as h and m. So h and m are going to stay as h and m, but we're going to change our slope to be 2. And we're going to change our b to our y-intercept, which is 10. So this equation right here represents this table. And we can use that to calculate any number of months how tall this tomato plant will be. I'm going to graph this using y's and x's. Y equals 2x plus 10. And you'll see it goes right through all the points. I believe if I change this to be m and this to be h, it'll let me use the correct variables here. So h can be, y can be h, and this can be m. So yep, there we go. I used the table of values that we made to create this equation, and look at that, all of our points go through it.